All right, so as we continue with our properties or laws of exponents, the last two we want to take a look at are zero and negative exponents. So I left up here the properties that we just went over, and we're going to take a look at, so I'm going to put them down here first. If I give you a to the 0, or if I give you a to the negative n, and I'm going to come back in just a moment and fill those in. So you can either write these all down again, which is not a bad idea, or continue where we left off. Before I tell you what the rule is, let's just investigate and let's do a little bit of deductive reasoning. So I suggest you watch this first before you write it down. Just kind of watch what I'm going to do over the next 30 seconds to a minute, and then if need be, pause and then write it down. Okay, so watch first before you write it down. I want to start with something that I know you know. I recommend you just watch first. So put your pencil down, just watch. I know you know what 2 to the 4th is. 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. And I know you know what 2 to the 3rd is. 2 times 2 times 2 is 8. And I know you know what 2 to the 2nd is. So let's just look at the pattern for a minute, without memorizing or anything else. If we just look at the pattern, you'll notice that as I decrease, as my exponent goes down by one integer, from 4 to 3 to 2, it's the same as dividing by 2. So as I decrease my exponent by 1, it's the same as dividing by 2. So if I decrease my exponent, it's the same as dividing by 2. So if I decrease my exponent, it's the same as dividing by 2. Well, what is 2 divided by 2? It's 1. If I keep going, if I decrease my exponent, I'm now at a negative 1. I divide by 2. 1 divided by 2. If I decrease my exponent, that's going to give me 1 divided by 4. If I decrease my exponent, so you may see a pattern. 1 over 2 cubed is 8, etc., etc., etc. So yes, I could have you memorize, but you can also analyze. I'm going to do it again. Because it does not matter what the base is. If I take 3 to the 4th, that's 81. 3 to the 3rd, I can find by dividing by 3. That's 27. 3 to the 2nd is the same as 27 divided by 3. 3 to the 1st, 9 divided by 3. 3 to the 0, 3 divided by 3. 3 to the negative 1, 1 divided by 3. 3 to the negative 2, 1 divided by 3 squared, or 9. And this pattern holds no matter what the base is. And so if we go back and we fill in our last two properties that we have, anytime you have a base raised to the 0 power, no matter what that base is, you will always get the identity. You will always get 1. So anything raised to the 0 power, well, other than 0, is 1. 0 to the 0 is for a definite another day, another class, another level of math. And then you'll notice that if the exponent was negative, Notice it just became the reciprocal, 1 over the number, 1 over the number. So this would become 1 over a to the n. Okay, so what we're going to do is we're going to look at some examples, because that's it. 5 minutes in and we've got the lesson over. Now it's all about the examples that we might see. Okay, so we're going to be taking a look mostly at monomials. So I'm going to start there. And you probably did not learn these in elementary school because the concept of negative numbers may not have been introduced as yet. So most of this practice is like the last section, where you're practicing monomials. Most of them. So we want to simplify. So there's no equal signs in them because we're simplifying. We're writing in easiest simplified form. So let's start with, oh, interesting. A couple of these I don't agree with, because you should never leave a negative or a 0 in an exponent. So I do not necessarily agree with a couple of these. Let's take a look at, here's number 22. P to the negative 1, Q to the negative 2, over P to the negative 3. Now you can always use the properties that we did over here, but I highly recommend that the first thing you do is rewrite the problem without negative exponents. So I'm going to write that down. Step 1. Rewrite with positive exponents. You're less likely to make a mistake if you take the 10 seconds or less and simply rewrite the problem. Now, what do I mean by that? Well, we said that anytime you have a negative exponent, it's just the reciprocal. Notice this is just the reciprocal. Instead of being in the numerator, we moved it to the denominator. So these are just reciprocals. So what I'm going to do is I'm going to take P to the negative 1, and the first thing I'm going to do is I'm going to bring that straight down and make that P to the positive 1. At the same time, I'm going to take the Q to the negative 2, bring it straight down, take its reciprocal, and make that Q to the positive 2. And we have one more that has a negative exponent. I'm going to take this P to the negative 3, and I'm going to bring it up and make its reciprocal be in the numerator. And now its exponent's positive. And now from here, this is just last section all over again. Reduce what you have, reduce the ones with the common base. One of these P's will reduce with one of these 3, leaving us with P to the second in the numerator. There are no Q's that would reduce, so I'm left with P to the second over Q to the second. So step 1, rewrite everything with positive exponents. Step 2, simplify using your laws of exponents. Okay, so let's take a look at 28. The expression 3x to the negative 2y, all of that being raised to the negative 1 power, over 2x y to the negative 2. All of that being raised to the 0 power. Okay? Well, you might notice something right away. Anything raised to the 0 power at all, and in this case I have an entire expression in parentheses, so that 0 sees everything. Anything to the 0 power is 1. So right away, I see that the denominator is now 1. And now you have a choice. You have a choice on what you want to do for the numerator. You have a choice, so I'm going to do it 2 different ways. I'm going to do this problem 2 different ways. Okay? You could use the properties of exponents, just like we did before, and anytime you have an expression like this raised to a power, you raise each piece individually. So this is the same as 3 to the negative 1. Let's see, when I have an expression raised to a power, I multiply, so that would become a positive 2. And then from here, I could simplify this by making sure I rewrite everything with a positive exponent. So anything with a negative exponent comes down. So the 3 to the negative 1 comes down. The y to the negative 1 comes down. But the x to the positive 2 stays exactly where it is. So one absolutely correct way is to use the properties of the laws of exponents and expand it. Or, some of you may have said, well, I get the fact that anything to the 0 power is 1. That's still the same. Notice, though, I have this entire expression that's being raised to this negative power. Well, if step 1 says rewrite with positive exponents, I'm going to take, and using this last property, I'm going to just use the reciprocal. So I'm going to take this entire expression and drop it to the denominator and make it a positive 1. So I would have to drop the entire expression as is, 3x to the negative 2y. And all I did was drop the entire thing down, and we know that 1 is a factor of everything, so 1 is still in the numerator. 1 is always there. And now what I've got, I don't think you can see that. This came all the way down and is now positive. Oh, I still don't think you can see that. Sorry, let me start that over. I think it just went off the board. Let me say that again. Okay, another way you could do this would be to say, since that entire numerator is raised to a negative power, I'm going to take this entire expression and drop it to the denominator, making the power positive. So whatever's inside there, don't change whatever's inside. The only thing you changed was that outside one that dropped it down. And now 1's a factor of everything, so 1 is still in the numerator. Now, we still have to rewrite with a positive exponent. Anything to the first power, okay, this is the same as 1 over 3x to the negative 2y when I use the property and multiply exponents. And now I can take just the factor that has a negative exponent and bring it up. That'll make that x to the positive 2 in the numerator, and the 3 and the y stay in the denominator. So you'll notice we got the exact same result no matter which way you happen to start it. Okay? And then let's take a look at number 40. And I'm not sure how many examples we need. So let's look at number 40. I'm trying to find one of each type. Number 40 says a to the 0 over b. Well, hopefully right now you're thinking, wait a minute, I know what a to the 0 is. All of that to the negative 2 power times a over b to the negative 2, I already forgot, to the negative 2. Okay? And some of you may start recognizing some shortcuts, because if it's a negative power, I just need the reciprocal, so I could flip that over on the inside. I'm going to just use the property that says if I have an expression raised to a power, I'm going to raise everything in the numerator and everything in the denominator. But first of all, hang on, a to the 0 is just 1. So now I have 1 over b to the negative 2. And a over b to the negative 2 to the negative 2. Okay. Now there's a lot of ways you can do the problem. I'm just going to use the properties. You might see it one way, I might see it another way. Let's just see if we get the same thing when we finish. So if I use the properties and I go, okay, 1 raised to the negative 2 and b raised to the negative 2. That literally gives me 1 to the negative 2 power and b to the negative 2 power times, and I'm going to do the same thing here. That's going to give me, in the numerator, a to the negative 2, but in the denominator, this is now going to give me a negative times a negative is a b to the positive 4. And now what I would do is then still start with making sure if it's a negative exponent, you take its reciprocal, make a positive exponent. So 1 to the negative 2, well, 1 to any power is 1. B to the negative 2 is going to come up. A to the negative 2 is going to drop down, become a positive 2. And the b to the 4 was already positive, so it stays where it was. Now that all the exponents are positive, now I'm going to simplify using laws of exponents. So the shortcut says whenever I'm dividing, I subtract powers. Notice, again, you could subtract and say 2 minus 4 is negative 2. Then you'd have to bring it down. Or I like to just look for which number is larger and know that the remaining bases are going to stay there. So 2 of these b's are going to cancel with 2 of these b's. The a stayed where it was. They have to be in the denominator. And of course, 1 is a factor of everything, so 1 would stay in the numerator. All right. So take your time. There's no reason to rush. No reason to rush. Make sure you read through the book. Look at some examples. If you need more examples, ask, or visit Khan Academy and look at 0 and negative exponents, or do a Google search and just search 0 and negative exponent examples, or examples with answers. Right? And there you go.